Solar tracking is a technology widely used in the area of harvesting solar energy. It is basically the mechanism that positions the solar panel so it will always face the sun. This way, it gives more power. There are many types of solar tracker, but mostly used is the single-axis solar tracker that face from east to west, or a more advanced one with a dual axis. This advanced one is obviously more accurate than the single axis. In this video, I will try to make a small prototype of the dual axis solar tracker. So let's get started. Firstly, let's understand how the sun moves in the sky. A good representation for this is this dome. This is the ground and where you put the solar panel. This is north, south, east, west. And this is the path of the sun. Big question, does the sun always stay in this path as months and seasons pass? Of course, the answer is no. The sun does not have a steady path. Actually, the sun changes its position slowly every day. This also depends where you are located in the world. This is how you see the sun if you are in 50 degrees north, or if you are in the equator where you receive a plenty of solar energy. This animation shows the typical path of the sun if you live in a country with 4 seasons. This will happen in summer solstice, in autumn equinox, and the winter will come and we only receive less sunlight. It will go back again to the middle part in spring equinox, and from time to time it goes back in summer path. Then the whole cycle repeats again. Let's go back in our dome. Let's have a summary of the movement of the sun. First, the sun will rise in the east and set to the west. And this is the first type of movement. The maximum angle is 180 degrees, but in reality it depends on your topography, which can cause shadows. The second type of movement is that the sun can tilt as the seasons pass. The maximum angle it can tilt is only 47 degrees. Now we know how the sun moves throughout the year. So the main point of the dual axis solar tracker is to compensate the two movements. Because it has a vertical axis, it can turn around and face east to west. And its horizontal axis is for tilting of the sun, which has a maximum of 47 degrees. Because of the two axes, it can perfectly face where the light is coming from. In our prototype, we just use analog circuitry. We can use a microcontroller, but I think it's easier to just use analog circuitry. Let's have a look in our circuit design. This is our sensor. Then we use 4 comparators for setting the sensitivity of the sensor. Since we have dual axis, we need 2 motors, and these 2 motors need 2 H-bridge. And lastly, the 8-volt regulator for generating the reference voltage. We have here the 4 LEDs as light sensor. This must be a green LED because it produces more voltage than other LEDs. For who doesn't know, an LED like this can also be used as a light sensor. When it is shined by the sun, the voltage across its terminals rises up to 1.6 volts. But I observed that the LEDs receive more light in this direction. So to balance the light it receives, I sanded the whole LED. We have two pairs of LEDs with a light separator in the middle. This pair is the sensor that controls the horizontal motor, while the other pair is for the vertical motor. Every positive of the LEDs are connected to the non-inverting input of the comparator. We can set the threshold voltage in the inverting input. In our case, we need a threshold voltage below 1.6 volts because remember, the maximum output of the green LED is 1.6 volts. These four trim pads here is the one responsible for adjusting the threshold voltage. It can be adjusted from 0 to 1.4 volts. In this way, we can adjust the sensitivity of each LED. Now, when an LED is generating voltage greater than the threshold voltage, this output will go high, and which is fed to the H-bridge. For who doesn't know, an H-bridge is a circuit that controls the motor rotation, specifically the direction of the rotation. This is the logic of the H-bridge. If both inputs are low, the motor won't turn. If input B is only in the high state, it will turn clockwise. Or if input A is only in the high state, it will turn counterclockwise. And when the two inputs are high, the motor will not turn. In my prototype here, instead of using 8 transistors, I just used this salvage LB1644 IC. This IC contains 2 H-bridge. The input logics are also the same, so there's no problem. It also saves a lot of space. I made the circuit in a small perf board and assembled all the parts. I made a low RPM gear rotator system from broken DVD players. You can see the 2 worm gear in every axis. It is useful because it breaks the gear connected next to it, so when the motor stops, the thing attached to it cannot rotate. I've got a plastic here and attached it to the horizontal axis, and I glued the sensor here at the top. I assembled all the parts, and there we have it. I tested it outside and it works, but not perfectly. You can see the small shadow here. By the way, the meaning of that shadow is that it is not perfectly facing the sun. So, I adjusted the threshold voltage. I finally find the perfect voltage and it works like a charm. Okay, it now works. But how does it basically works? This is how the LDR are arranged together in order for it to work. As you can see, we have perpendicular separators here. So when it is not angled directly to the sun, one of the LED will be shadowed. In this condition, one input is on, and therefore it turns the motor. The sensor starts to tilt, and eventually both LEDs now receive the light. But remember, if both two inputs are high, or two LEDs are high, or two LEDs receive light, it stops the motor. We can just also apply it for the other axis by putting the sensors in this way. So it knows where the light is coming from, either from the east or west. The two axes works together until it perfectly faces the sun. As we can see, there is no shadow in the 4 LEDs, meaning they are perfectly facing the sun. And now you know how it works. Even if I move it in different positions, the sensor still finds and tracks the sun. For me, this design was great and pretty straightforward. If you like this video, please hit like, share and subscribe. Thanks for the view. And remember, be innovative.